Hello YouTube, XCT here. In this video we are going to solve Developer, a pretty hard Linux machine on HackTheBox which involves cross-site scripting, tab nabbing and reversing a Rust binary. So as always we start with a port scan and we can see that we have just SSH and an Apache web server. So let's have a look at this website. And here we have some kind of CTF platform and you can make an account and then log in. I've already done it. And then you get to this internal area where you can view your profile. And you can also try to solve the challenges in the various categories here, right? We're just going to solve the pawn one here, but you can really pick any of the challenges. And the idea is that maybe if we solve one of the challenges, we get more options on the site. As you can see, we can now just download and solve, and maybe afterwards we have more options, right? That's the idea here. So let's look at this pawn me binary here. We can see it's an ELF 64-bit binary. Let's load that in GDB. Do a quick check sec. We have NX, Pi, no canary. Let's just start by seeing what this thing is actually doing. It seems it just wants us to enter some kind of password here. Okay, and then it's telling us if it's a correct or wrong password. So since this is a pawn challenge, let's just try to send something big here. And I'm just going to use Python here to create a bunch of A's. Let's do 30. And this actually prints the flag, which is pretty interesting. I expected we have to write some kind of exploit, but I'll take it. And now we should be able to submit this flag here. Right, let's see if anything changed on this page. It's now completed. And now there's one new option here. We actually have the chance to submit a walkthrough. And it's asking us for a URL. So we don't upload it, but it tries to directly reference it from our box, it seems. So let's just try to put our IP here and see if we get a hit on our web server. Yeah, and after a minute or so, you can see that we actually get a request for the file. So something on the server is basically clicking the link we sent it. So the next thing we're going to do is we're going to send a link to this payload.html file just to see if it would execute JavaScript. And if that's the case, it would try to load this payload.js file from our box. So let's see if it actually does that. And yeah, we can see that we can indeed include a script. So it tried to get the payload.js script here from our box. So we still don't know what we can do with that, right? So let's see if we can find some endpoint that would be interesting to target. I'm just going to fusted here. And it's just a shortcut for FFAF. Well, you can see that there are a few endpoints here that have admin as a word in them. So it's kind of unlikely it's exactly this as a badge. It seems like it's just looking for the word admin and then redirecting. So let's just try the admin endpoint here and see if that one actually exists. And this admin endpoint indeed exists, and we can see it's a Django backend login. It's also telling us that our user exists, but it doesn't have access to the backend because, well, we are not an admin, right? So let's think what we can actually do here. We assume that some script or some simulated person is basically clicking the walkthrough link we sent him, and imagine that there's also an admin in the Django backend, right? So if we could execute some cross-site scripting attack, we might be able to do some session writing to create a new Django administrator, or use the administrator privileges to do something else that's interesting, like promoting our user to an administrator or something like that. But there's a problem here because if we execute the XSS on our box, we are basically not in the context of the site, and so CORS would prevent us from doing anything interesting to the application. So what we basically need is not just an XSS on the site we host, we need one inside this application. So let's try to find one. And we're still going to look for this submit thing here. So if I submit something here and then I go to this profile page, it's actually being inserted here as a link. If this bot thing is clicking this link, maybe we can do some XSS here, like an on-click handler or something like that. So one thing you can do here is we can go to burp and then this submit and just do an active scan. And this will actually find an XSS here, but it takes a long amount of time. So I'm just going to paste the one that eventually worked here to save some time. So let's submit that again, send that to the repeater. And this is the actual payload that burp found. We have this JavaScript here with onClick and document write, and then we write a script, which is just getting payload.js from our box again. But this time, this is basically executing in the context of the application, so it's a lot more useful for us. So let's send that and see how that behaves here. Now you can see at the bottom that the link here changed and we have our script thing. So now we just gotta wait and see if it actually includes payload.js again from our box. Yeah, and we can see that it actually worked. We get a hit here trying to load payload.js again, but this time from an XSS context in the web application. So that's really good for us. Now we have to think about what kind of payload we want to create, right? What I ended up doing is I tried to create a script that would create or basically would promote our existing user to be an administrator in the application. And building the payload can be a bit tricky. So what I did when I solved the box the first time is just create a local Django installation and see how all the requests look like. So to save some time, I'm just going to show you the payload. And it basically looks like that. First, you request this change page for a specific user, and we don't really know which ID our user has, so you have to count that up until it works. But basically, this is the page in the admin backend where you can change particular things about a user. And what we want to change is we want to make him a super user. So we set is super user on here and is dev on. And basically these are just copy pasted from doing it in the GUI and then observing the requests in burp, right? There's one issue here, there's a CSRF token. But CSRF tokens are basically useless as soon as you have a cross-site scripting, because we can just load this change page, read the CSRF token, and then use it on the post request to the same page to actually change the values. So as soon as you have an XSS, it doesn't matter anymore that there's a CSRF token. So to actually use this payload, all we have to do is to change payload to payload admin, because that's how I called it here. And here we can see that it actually got the file from our box. And let's see if that actually made our user an admin or not, because that's in the end what we wanted to achieve. So let's go to admin here again. And you can see that it worked. The user ID was correct. And now we are an admin in the Django backend here. Let's explore that a bit. You can see that there are a couple of other users, but no useful information we could use right now. Let's look at the challenges. Nothing too interesting here either. Here you can see the user IDs. So 8 is probably what you will get as well when you register the first user. Here sites is pretty interesting. It's showing us a new site we didn't know before, which is developer-sentry.developer.htb. So let's save that. Actually here profiles, there's something else. There's something here that looks like a password. So let's save that as well. Other than that, I don't see anything too interesting. So now let's have a look at the Sentry page here. Okay, we have to log in here. I tried the password we just saw with all the users, but none of that worked. So we're just going to create our own user here. You can see a version here that might be useful later on. But there isn't too much going on here either. We have a few other users here, so let's copy that. So let's look for vulnerabilities for the Sentry application. There's an RCE here on ExploitDB, and there's also this Synactive advisory here. And this one is pretty interesting. It's also for this version we have here. And it's telling us here 802. I think we had 800, so it should still work. Yeah, here it's telling us in which versions it's fixed. So we're definitely below that one. And there seems to be a deserialization vulnerability. Let's scroll down to the proof of concept. This is basically creating a base64 encoded pickled object. And then it seems we just have to paste it into an ordered log entry in order to be executed. This sounds pretty good, but we don't have permissions to do that. So we see here that Sentry is also a Django application, but our user that we just registered is of course not an admin. So it's a bit tricky at this point. And this is where I got a bit stuck. It went really smooth, and then at this point we hit a wall. There's really nothing you can do here because you can't become an admin from this point on. The reason you can't really proceed here is that the first step was intended to be a bit different. And what we're actually supposed to do is this reverse tab nabbing. So essentially what we can do is, because this link the admin was clicking earlier has this target equals blank, and we can control the href of the link, we can change the window opener location and make it a malicious page. How this plays out is, if I am in this application here and I click on the link, let's do that for once. Let me just submit something here. Now we have this link, and if we go to inspect, you can see the target equals blank here. That's exactly what we need for this tab nabbing. And now if we click that, this opens in a new tab. And this new tab can actually change what's in the old tab. So the idea is, if you open this link and you close it again and you go back to the page you were before, it can have changed here to some phishing thing. And this is exactly what we are trying to do. So let's look at this payload here. We are just doing what was in the post. We are replacing the window opener parent location with this URL. And it's basically the same URL you would get as if you would log into the application, just that it doesn't say developer.hdb here, but our IP. So I think the box really requires that these paths match up. So make sure it's the same one. And then what I did was I used httrack to clone the original login and save it to this fish folder here. I'm not going to do it again because I already did it, but that's basically how you clone the page. And inside this folder, you get this developer.hdb folder here. And there it basically replicates the folder structure like we saw it in the path. So there's accounts here now, and inside accounts, there's logins. And then there's an index.html. And this is the cloned login page. So there's one thing we have to change here. If you clone this in action, it will point to the original host, and we don't want that. So in front of here, we have to remove the http developer.hdb, which is here by default, and just leave the path here. So it actually posts again to our page. And the idea is that they will try to log in, and because they are on our page and not on the page they expect, we will get the login credentials. So in this folder, we also have this paytab.html, the payload I just showed you. And now let's see if we actually can get some credentials here. You can't just use a normal http.server here, because we also want to see post data and we want to see headers. So in order to get them, we have to use a custom script here, which is this one in my case. You can also find this in the blog post to this video if you want to copy paste it. And basically it's just wrapping the simple HTTP servers, so you get the headers on GET requests and also on POST requests. But on POST, additionally, it's also printing the POST data. So this is useful for us in this situation. Let's run that. And now we just have to point it to this paytab.html. So at this point, we don't really need the XSS anymore. So let's just paste our payload here and hope that we get a hit on our server. You can see that our paytab.html was hit, and it's going to accounts login, and it's then trying to log in. And it's sending us some data here, which is very interesting for us. It includes here the admin password. Now you can see why we couldn't proceed before, because we really need this password. It's reused on the Sentry page. So if you don't do the tab nabbing, just the XSS, you have no way to proceed. And also this whole bot can break. So I had it a few times by trying to do the box that the bot would just break and then you have to reset the whole thing. So if you don't get a request, just reset the box and do it again. So let's now try to log into this page. We have Karl and Jacob, so we can try both of them. Let's log out first. Try Karl with the password we just got. Let's see if we made a mistake. Don't think so. Let's try the other user, which is Jacob. And here we go. We can log into the application and now we have a lot more options here. So that means now we are a privileged user. And now we are in the Django backend and we are actually an administrator, even though on the page it didn't say that we are one. So let's continue here. This is the one where we need to be. Let's see what we actually need to do here. It's telling us to create or edit an audit log entry and then paste the payload. So first of all, we gotta run this payload here. And I just copy pasted that. And the only thing we have to change is we have to change the payload we want to execute here at the bottom. I'm going to get the reverse shell from my box, save it in dev shm, and then execute it with bash. So let's execute that. And we get two payloads which we can use. First of all, let's make sure we really have our payload here. Then let's start our web server again. Also, I want to start a listener in case this whole thing works, right? So let's copy this payload. Let's just change this entry here. Right, let's just put the payload here and see if we get a request to our box. And yeah, our file was requested, so this exploit seems to work. Let's do the other payload. And here we go. We actually get a shell on the system. And we are dub data. Okay, so at this point, it's a whole lot of enumeration. Basically, you want to see the directory are we in, var Sentry. Right, so let's see if there are any configuration files for the Sentry thing. I'm just going to grab the password here. These are clearly too many hits. Let's see if there are any configuration files on etc for the Sentry thing. Yeah, there's a folder here. Let's go there. And there are only two files here, so this time it's a bit easier. Let's see. Okay, this one has a secret. We don't know yet what to do with that one. So let's look at the other one as well. We got a Redis install and we got a Redis password here. So this is definitely something we gotta save. And also it should have some kind of database, right? Yeah, so here we have some database credentials. So to connect to the database, we need a PTY. So let's get one. See if that works. Password for Sentry, we have one here. And it's showing us a lot of tables. Okay, let's see if there are any good ones here. Maybe off user, right? Maybe there's some password reuse or something like that. So let's do a select here, list everything from off user. And here we get something interesting. We get two hashes, one for Jacob, which we already know the password for, and one for Karl. So just copy both of them for now. And now we want to crack this. And actually, it's a bit difficult to do that. If you know how to do it with John, please let me know. Somehow didn't want to crack. Yeah, but so first of all, let's save that here as karl.hash. And we just copy in the whole thing. And if you Google for that prefix here, and you can see the kind of same format here, and it's telling us Django is 10,000. So this is something we can certainly try. So let's run hashcat here. And it already cracked it before, so it's not doing it now, but I think it was fairly quick. So let's try that with --show. And here we get the actual password, which is insane clown pose. And now finally we can use this password to SSH into the box. So let's see, and we got the user flag here. So the first thing we always do when we get a shell is to check ID for special groups, but also check sudo, see if we can execute anything interesting. And there's indeed one program here we can execute. if there's nothing in sudo, nothing in ID, you can just run a private script, right? But we can execute that one here. So let's just do that and see what it does. Welcome to the CyberGeek Super Secure Login Portal. Enter your password to access this super user. But we don't know the password, so we can't really do anything here. So this application seems to somehow validate our password. And I would assume if we would enter the correct password, it would allow us to become root in some kind of way. Since we don't know how this thing works, we have to do some analysis. So let's do a quick strings here on the thing first. And these are a lot of strings. And if you've seen Rust programs before, this is a good hint at that this could be a Rust program. We can run a quick strace here, see if anything interesting is executed. But we can't really see that much at this point. Let's enter something here. Yeah, it is not showing us much. So we probably have to end up copying that thing to our box and to analyze it a bit. So I already copied the binary to my box here, and you can see it's a 64-bit executable. Usually I would probably try to solve it with Anger, but in this case it's not working because some cryptography is involved. So we cannot do that here. Instead, we're going to analyze it in IDA and see if we can understand a bit what the binary is actually doing. So let's have a look at this binary in IDA. So when we open this, it looks like that. Let's see if we can find the main function here. Here we go. Doesn't look too good. Maybe we just use this one. Yeah, this looks like the real main function. We have a couple of prints here and there's a read line. So it's probably printing the banner and then reading our input, right? So let's scroll a bit through that and see if we can find out anything on what this program is doing. And honestly, it's a bit tough to read for me. I'm not the best at this, so I'm just going to try to scroll a bit through that, see if I can find any pieces here. So here's one interesting bit. It's using AES in counter mode, which basically leads to a XOR stream. So this is pretty interesting. Maybe we can do something with that. And also here it's allocating a certain size, which is hex 20 or 32. So this might be the size of the input. I'm not 100% sure from looking at this, but it's just a guess, right? Let's scroll a bit further. There's some more crypto stuff here. Here it says synchronous stream cipher. That's maybe the XOR cipher. And also it has hex 20 here again, which is 32. So yeah, maybe this is really the input length. But let's continue. And this piece here is the most interesting one, because here we can see a couple of moves and then two compares here. And depending on the result, you either go to this block or the other route. And this looks like this is the block we want to reach, simply because there's a couple of prints and then there's again a read line. So if you enter a wrong password, there's not another read line. But I guess if you enter the correct one, there will be. So this is the block we want to reach. And I really didn't get more information from reversing. So the best thing I can do at this point is just break here at this position and then look at the register values and so on. Also, we can just, when we are at this position, we can just change the 0 flag and see if we actually get to the point where we could authenticate. So let's actually try to debug that. Now we want to break at the position we just saw. So let's look what this offset was. And we can see in IDA it's 21E. So let's try that just like that. And now we run it. You can see we need to enter the password. And remember, we assumed it would be 32 characters. So let's enter something with 32 characters. I just chose zeros here, but it doesn't really matter. You can use anything, right? And then we hit our breakpoint. So this is exactly the block we just saw in IDA. It's a couple of moves, the compares here, and then there's the jump at the end. So let's step through this. So now we are at this jump, but it's not taken. So one thing we can do, like I mentioned, is to flip the 0 flag. So let's do that. And now you can see that PwnDebug updated this little arrow here, and we're actually taking the jump now. So let's step here and maybe just continue. And you can see that this is indeed the correct place because now we have successfully authenticated. And it seems now we can enter some kind of SSH key. And I assume it will just be copied to the authorized keys file. So while this is nice that we could skip authentication, it won't work on the remote end because we're not allowed to debug a privileged process. So we can't use that to bypass the authentication. And we do have to understand how this crypto stuff is working. So basically in this graphic, you can see how AES CTR is working. Basically you have a nonce and a counter. For each block, the counter is counted up. And what's happening, this value is being used together with the key to create a XOR stream. And then when you take the plain text, it will be XORed against this XOR stream that was just generated here. And basically, if we, instead of a normal plain text, would provide all 0 bytes here, what will happen is that the 0 bytes will get XORed against this XOR stream, and we just get the XOR stream here as a ciphertext. So this will allow us to get the raw XOR stream. And if we have the stream, we could potentially decrypt whatever is in memory. So what the program is basically doing is it's loading from a file a password, and it's then encrypting this password. And we also enter a password. It's also encrypting this one, and then it's comparing. So if we provide all 0 bytes here, we get the XOR stream, and if we know where in memory the loaded encrypted password is, we can XOR them against each other to obtain the clear text password. So because we really can't enter null bytes on the command prompt, what we'll do is we are going to break here right after the read line at this position, and hope we can see our input buffer and then replace the contents in memory with null bytes. So let's try that. So let's see what we did here. I set the breakpoint we just saw plus the one from before. Then I just entered some dummy input here again. Remember, these are not null bytes, these are just ASCII zeros. And then if we look at the registers, we can see our input here. So we have a pointer to our input buffer. And now I'm replacing this content with actual null bytes. So here, this call to memcopy will basically write zeros there. And if we now do info registers, let's look at the content of RCX. And now we can see that there's actual null bytes here. So let's continue here. And now we are again at this point where it compares basically the loaded and encrypted password against our input that was XORed against the XOR stream. So let's just note all the registers here for now. We are going to step once and then look at XM0. Then we're going to step again. Then we look at XMM1 and the same for XMM2. So let's store the values here. And now we can see that XMM2 is compared to XMM0, which are different values. Let's write that here down as well. All right, let's step some more. Now we print the 0 again, get this value. All right, so in these values, we basically have our input XORed against the XOR stream, which just ends up being the XOR stream. And we also have the loaded password, which was encrypted. So now we just gotta XOR this against each other, and we should be able to get the actual password back. One thing to do that is in CyberChef, so let's do that. And if we just concatenate the values, you can see that we get something that resembles a password here. So let's look at this again to make clear what are used as an input. This value and then this value, right? And the same for the key, it's this value followed by this value. But there's some problem here, which basically comes from the endianness, but we can fix that in CyberChef. So let's do that. there is a swap endianance gadget here. And if we use that gadget, you can see that we finally get a real password here that looks pretty much correct. So let's copy that one. And now it's time to test that. So let's just run this Authenticator binary here. Put in this password. And here we go. We are authenticated. Now it wants some SSH keys. So let's just generate one. It's telling us we can now authenticate as root. Let's try that. And here we go, we finally got the root shell. And we can read the flag. So that's it for this box. Thank you for watching, and if you like this kind of content and want to see more of it, please consider subscribing to the channel and clicking the like button. Thank you.